The city that sees in the dark. How iLamp and AI factories transform every street light into the intelligent nervous system of HYDC Smart Cities. A strategic narrative. Hello, I'm Charles Cortland Hooper, PhD, Chief Systems Integrator. I'm here to share how the amazing HYDC Smart Cities initiative is driven by some equally amazing technologies you may not even know are possible, and that only HYDC has them as an extraordinary living system under its umbrella, making the full promise of a smart city a reality, and HYDC Smart Cities different from all other partial attempts by others. The extraordinary iLamp is just one of them. Prologue. The street light that changed everything. There are approximately 55 million streetlights on the surface of this planet. They line every road, every highway, every boulevard, every alley in every city and town and village, from Mumbai to Miami, from Lagos to London. They have been doing the same job since Thomas Edison first strung carbon filament wire through a glass bulb in 1879, burning electricity to push back the dark. For 145 years, the street light has been purely a cost center. Cities pay to install them. Cities pay to power them. Cities pay to maintain them. The ongoing maintenance cost of a conventional street light over a 5-year period routinely equals 100% of its original purchase and installation price. Every light pole on every street in every city in the world is a recurring liability on a municipal balance sheet. Necessary, unavoidable, and expensive. Now imagine that every one of those 55 million streetlights was also a solar-powered AI computer, a safety sensor, a traffic analyst, an environmental monitor, a 5G communications node, a drone guidance and charging station, an edge computing facility selling GPU processing time to cloud AI workloads around the world, 24 hours a day, 7 days a week, 365 days a year, generating revenue that flows back to the city, the owner, and the investor. Imagine infrastructure that does not cost money to run, infrastructure that earns it. That is iLamp. And the story of how it was built, what it does, and why it belongs at the beating heart of every CityWorks smart city is one of the most compelling technology convergences of our era, a story about what happens when a streetlight stops being furniture and becomes intelligence. Most infrastructure costs money to run. iLamp earns it. This is directly comparable to when Edison and Westinghouse were wiring cities, just a modern, much-needed, and kind of obvious improvement. Part 1. What iLamp actually is. To understand iLamp, you need to set aside everything you think you know about streetlights. A streetlight, as currently understood, is a pole, a fixture, a lamp, and a wire connecting it to the grid. It turns on at dusk. It turns off at dawn. It illuminates a patch of road. That is all it does. iLamp is not a streetlight with some features added. It is a fully autonomous, smart infrastructure node that happens to also illuminate a patch of road. The distinction matters enormously because the illumination is almost incidental to the platform's broader function. The hardware stack, 7 technologies in one unit. Inside every iLamp unit, 7 distinct technology systems operate simultaneously, integrated into a single weatherproof, self-powered, self-cleaning package that requires no grid connection, no civil works beyond the installation of a pole, and no ongoing energy costs. NVIDIA Jetson AGX, Orin, Embedded AI Compute. The Jetson AGX. Orin is NVIDIA's most powerful edge AI module, the same class of processor used in autonomous vehicles, robotics, and industrial AI systems. It delivers up to 275 TOPS of AI performance in a module the size of a credit card. Embedded inside every iLamp, it transforms the unit into a local AI factory, processing sensor data, running computer vision algorithms, executing traffic analysis, and simultaneously selling spare GPU compute cycles to cloud AI workloads. This is the brain of the operation. Adaptive LED Array. Light that thinks. iLamp's LED array is not static. It is continuously tuned by the embedded AI based on real-time measurements of ambient light levels, weather conditions, and detected human and vehicle presence. The system only illuminates when and at the intensity actually needed, dramatically extending bulb lifespan, reducing energy consumption, and ensuring that light output is always optimized for the actual conditions on the ground rather than a fixed schedule programmed into a timer. AI camera and sensor suite, eyes and ears for the city. A 360-degree camera system with optical recognition technology provides continuous situational awareness in every direction simultaneously. The AI processes the video feed locally on the Jetson module to perform object detection, pedestrian and vehicle counting, behavioral analysis, traffic flow measurement, incident detection, and where required, gunshot acoustic detection with automatic emergency services notification. The camera sees, the AI understands, the city responds. 4G and 5G connectivity, the communications hub. Every iLamp unit is a 4G and 5G communications node, providing both cloud connectivity for its own data streams and Wi-Fi hotspot services for residents and pedestrians in its immediate vicinity. As optional hardware upgrades, full cellular tower integration transforms iLamp into the primary communications infrastructure for an entire neighborhood, eliminating the need for separate cellular tower deployments and their associated planning permissions, construction costs, and ongoing lease agreements. Solar panel and battery, completely off-grid. iLamp generates all of its own power on-device. Self-cleaning solar panels, resistant to dirt, dust, sand, storms, and flooding, charge an onboard battery system that provides continuous operation through nights, cloudy periods, and adverse weather. There is no dependency on the grid. When the municipal power fails, iLamp keeps working. When a disaster strikes and grid infrastructure goes down, iLamp stays up, maintaining lighting, communications, and surveillance exactly when they are most needed. Drone guidance and charging. iLamp integrates with the Drone Ready platform to provide guidance beacons and charging stations for autonomous drone networks. As commercial drone delivery, aerial inspection, and forest fire prevention applications scale globally, iLamp becomes the physical infrastructure layer that makes citywide drone operations possible, a landing pad and charging dock embedded invisibly into the street lighting network. EV charging integration. Grid-enabled iLamp units serve as electric vehicle charging stations, with revenue from charging sessions deposited directly to the unit owner's account. As EV adoption accelerates and the charging infrastructure deficit becomes one of the defining infrastructure challenges of the decade, iLamp offers a deployment pathway that requires no dedicated construction. The charger goes wherever the light pole stands. 7 technologies, 1 pole, 0 grid dependency, and the entire system not only pays for itself, but generates ongoing revenue from multiple streams simultaneously. This is the fundamental architectural insight that distinguishes iLamp from every smart city technology that preceded it. iLamp does not add intelligence to existing infrastructure. It replaces the infrastructure itself with intelligence, and then earns revenue from every dimension of that intelligence, simultaneously, around the clock. Part 2. The Revenue Architecture. Infrastructure that earns. The most radical thing about iLamp is not the technology. The technology, NVIDIA Edge AI, solar power, 5G, 360 cameras, is sophisticated but increasingly familiar. The radical thing is the business model, infrastructure that generates more revenue than it costs to operate from day one of deployment. This has never existed before. Infrastructure, roads, bridges, water pipes, electrical grids, streetlights, has always been a cost to be managed, a burden to be financed, a liability to be maintained. The idea that a piece of street infrastructure could be a revenue-generating asset, producing multiple independent income streams simultaneously, is a conceptual break from 150 years of infrastructure economics. 3 revenue streams, 1 unit. Every iLamp unit generates revenue from 3 independent sources, each of which would justify the unit's deployment cost on its own. The first stream is lighting as a service. The host authority, a city, a township, a property developer, a private road owner, pays a service fee for the lighting that iLamp provides. This replaces the existing model in which the authority purchases lights, pays for power, and absorbs maintenance costs indefinitely. Under the iLamp model, the authority pays a predictable service fee and receives superior lighting, superior reliability, and zero maintenance responsibility. The economics are immediately favorable compared to conventional street lighting. The second stream is GPU compute revenue. This is where iLamp departs entirely from anything in the history of infrastructure finance, the NVIDIA Jetson AGX. Orin embedded in every unit produces AI compute capacity in excess of what local sensing and camera processing requires. That surplus compute is sold through the AI Factories platform to cloud AI workloads running anywhere in the world. Organizations running machine learning training, inference operations, computer vision pipelines, and AI-intensive applications purchase compute time on the global iLamp network. AI Factories distributes that revenue at 9 cents per unit per hour, operating 24 hours a day, 365 days a year. A single unit generates approximately $787 per year from GPU compute revenue alone. A network of 10,000 units generates $7.87 million annually from compute sales, with zero incremental operating cost because the solar panels are already powering the system. The third stream is data intelligence revenue. The traffic analysis, pedestrian counting, air quality measurements, weather data, and environmental monitoring that iLamp's sensor suite generates continuously has substantial commercial value to urban planners, transportation engineers, retail businesses, insurance companies, logistics operators, and government agencies. This data, collected at street level, processed locally by the embedded AI, and aggregated across the network, is a product that cities and private operators currently spend significant budgets trying to acquire through separate sensor deployments. iLamp produces it as a byproduct of its primary function. AI Factories, the financial vehicle that scales the network. AI Factories Limited is the financial architecture that captures and scales the compute revenue produced by iLamp's global deployment. The relationship between iLamp and AI Factories is precise. iLamp is the hardware network. AI Factories is the financial network built on top of it. Every iLamp unit is, in the AI Factories framework, a small AI factory, a node in what becomes, at scale, the world's largest distributed supercomputer embedded in physical city infrastructure. The investment structure is designed with remarkable clarity. Units are available on the ILO-CX platform at $10 per unit, with 1 million units in issue. GPU compute revenue of 9 cents per unit per hour flows back to unit holders, creating what AI Factories describes as a self-liquidating return structure. The revenue generated by the deployed infrastructure pays back the capital invested in it, without speculation on future adoption curves, because the infrastructure is already contracted and the revenue model is proven before the first unit is placed. The deployment foundation is already established. Infrastructure is contracted through CPG territorial license holders in more than 30 locations across Africa, the Americas, Europe, the Middle East, and Asia Pacific. The territorial license network means that iLamp deployments are not dependent on individual sales to individual cities. They are executed through master agreements with regional partners who hold the rights to deploy within defined geographic territories. This architecture allows the network to scale without a corresponding linear increase in sales and deployment overhead. At 1,000 units deployed, iLamp is a smart street lighting network. At 10,000 units, it is a distributed AI supercomputer embedded in city infrastructure. At 55 million units, the number of streetlights currently in the world, it is the largest compute network ever built, powered entirely by the sun. Part 3. The AI Factories Network, a distributed supercomputer in the street. To appreciate the full ambition of AI factories, you need to understand what distributed computing is and why the iLamp network represents something genuinely unprecedented in the history of computing infrastructure. A conventional data center is a centralized facility, a large building full of servers, cooled by industrial air conditioning systems, powered by utility electricity, connected to the internet by high-capacity fiber, and operated by a staff of engineers and technicians. It is enormously expensive to build, expensive to power, expensive to cool, and expensive to maintain. It is also a single point of failure. If the building loses power, loses connectivity, or suffers a physical disaster, the compute capacity it provides disappears entirely. The global demand for AI compute is growing at a pace that centralized data centers cannot possibly match. Every large language model, every image recognition system, every autonomous vehicle, every predictive analytics platform, every real-time translation service consumes compute capacity. The world's data centers are already running near capacity, and the demand curve for AI computation is still in its early exponential phase. The infrastructure does not exist to support the AI applications that are already being developed, let alone the ones that will be developed over the next decade. Edge computing, the architecture the world needs. The solution that AI Factories is building, distributed edge computing embedded in physical infrastructure, addresses this crisis from a completely different architectural direction. Rather than concentrating compute in large, centralized facilities, edge computing distributes processing capacity to thousands or millions of small nodes positioned physically close to the data they process and the users they serve. Data that is processed at the edge does not need to travel to a central data center and back. It is processed where it is generated in milliseconds with no transmission latency. For the applications that matter most in a smart city, real-time traffic signal optimization, instant safety alert response, continuous environmental monitoring, live emergency services coordination, edge computing is not just more efficient than centralized cloud processing. It is the only architecture that can meet the latency requirements. When an AI system detects a vehicle running a red light or identifies a developing crowd crush at a public event, the response must happen in milliseconds. Sending data to a cloud data center and waiting for a response is not fast enough. Processing it locally on the NVIDIA Jetson embedded in the iLamp unit on the corner is. The AI Factories network does not compete with centralized cloud computing. It complements it. The iLamp edge nodes process time-sensitive, location-specific data locally. They sell surplus compute capacity to cloud workloads that are not time-sensitive but benefit from distributed geographic availability. The two architectures work together, with the AI Factories network providing the physical edge layer that sits between the raw data of the city and the analytical intelligence of the cloud. The scale thesis: 55 million units. The AI Factories vision is explicitly global and explicitly ambitious. There are 55 million streetlights in the world. Every one of them is a candidate for replacement with an iLamp unit. Every replacement adds another NVIDIA Jetson AI node to the distributed network. Every node generates 9 cents of compute revenue per hour. Every node contributes its sensor data to the global intelligence network. Every node provides a 5G communications point, a drone charging station, a safety monitoring system, and an EV charging location. At 55 million units, full replacement of the world's existing street lighting infrastructure, The AI Factories network becomes the largest distributed computing system ever assembled. More compute capacity than the combined output of every data center currently operating on Earth, distributed across the physical surface of every city on every continent, powered entirely by solar energy, requiring no central facility, no centralized cooling, and no centralized maintenance. This is not a projection for the distant future. It is the logical endpoint of a deployment strategy that is already underway in 30 or more contracted territories, with a proven revenue model, a production-ready hardware platform, and a financial structure designed specifically to fund global scaling without requiring speculative capital. The world's largest AI supercomputer will not be built in a data center in Virginia or a server farm in Iceland. It will be built in the streets, one lamppost at a time, powered by the sun, earning revenue around the clock. Part 4. CityWorks, the perfect host environment. To understand why iLamp and AI Factories belong inside CityWorks, you first need to understand what CityWorks is actually trying to build, and why the intelligence layer is as important as any physical infrastructure. Huntington York Development Corporation is not building housing. It is engineering complete urban ecosystems, cities designed from first principles to be intelligent, self-sustaining, and continuously improving. The CityWorks platform is the digital and physical spine of those cities, a 7-layer IoT architecture connecting every building, every utility, every resident service, and every piece of infrastructure into a single intelligent network that monitors, manages, and optimizes everything it touches. The scale of what CityWorks is addressing is extraordinary. India faces a housing deficit of 93 million units by 2036. 416 million people will migrate from rural villages to Indian cities between now and 2050. Prime Minister Modi's Smart Cities mission has committed to 500 new smart cities with $1.5 trillion of infrastructure investment. And at the center of this transformation sits Bengaluru, the fastest changing city on Earth according to Jones Lang LaSalle, where HYDC's Phase 1 Eco-Smart Village is shovel-ready, fully permitted, and waiting for construction to begin. CityWorks addresses this opportunity through 8 integrated systems: green townships, intelligent water management, embedded renewable energy, vertical farming, carbon-neutral infrastructure, the CITIWERXS digital platform, cultural integration, and the smart energy and intelligence grid that ties everything together. Each system generates data. Each system requires management. Each system benefits from continuous distributed sensing. And every one of those systems becomes smarter, more efficient, and more responsive when iLamp's sensor network is embedded throughout the city's physical infrastructure. The data gap in every smart city. Every smart city platform, including CityWorks, faces a fundamental challenge. The intelligence of the system is only as good as the data feeding it. You cannot optimize what you cannot measure. You cannot respond to what you cannot detect. The CityWorks platform can analyze, visualize, and act on data from every sensor and meter in the township, but only if that data is being collected in sufficient density, at sufficient frequency, and at sufficient granularity across the entire city surface. This is the data gap. Filling it requires sensors deployed at street level throughout the city, measuring everything that matters continuously: traffic, pedestrian flow, air quality, noise levels, environmental conditions, safety incidents, energy consumption, infrastructure health. The cost of deploying a dedicated sensor network for each of these measurement domains, separate hardware, separate power infrastructure, separate communications, separate maintenance, is prohibitive at any meaningful scale. iLamp fills the data gap entirely, not as a separate deployment, not as an additional cost, but as the street lighting infrastructure that was going to be installed anyway, now doing 10 jobs simultaneously for a total cost that is lower than conventional street lights alone. iLamp does not add a sensor network to CityWorks. It makes the street lighting network into the sensor network, eliminating a separate deployment entirely and turning a cost into a revenue stream in the same motion. Part 5. The integration. iLamp inside CityWorks. The convergence of iLamp's hardware intelligence and the CityWorks' digital platform is not coincidental. When you lay the data requirements of a living smart city over the capabilities of the iLamp sensor network, the fit is precise at every point. Here is what that integration looks like in practice across every dimension of the CityWorks city. Application 1. Real-time traffic and mobility intelligence. Every CityWorks township needs to manage the movement of tens of thousands of residents, vehicles, delivery systems, and eventually autonomous vehicles through its streets and public spaces. Traffic flow optimization, parking management, pedestrian safety, and emergency vehicle routing all depend on real-time data about what is moving where, at what speed, in what density. An iLamp network deployed throughout the township's road network provides this data continuously. The 360-degree AI camera on every pole counts every vehicle, classifies every vehicle type, measures every vehicle speed, detects every queue, and identifies every anomaly: a wrong-way driver, a stalled vehicle blocking an intersection, a pedestrian walking in a cycle lane. The CityWorks platform ingests this data stream in real time, feeds it to its traffic management algorithms, and dynamically adjusts signal timing, routing recommendations, and emergency dispatch priorities. The city thinks, the city responds, the city learns. As CityWorks townships integrate autonomous vehicle infrastructure, a core element of the HYDC Smart Mobility vision, the iLamp network becomes the physical guidance system that autonomous vehicles use to navigate. Every iLamp pole is a position beacon, a live data source, and a communications relay for vehicles operating in its vicinity. The street lighting network becomes, in effect, the nervous system of the city's autonomous transport layer. Application 2. Environmental monitoring and sustainability reporting. CityWorks townships are designed to 50 to 60% reduction in carbon footprint compared to conventional urban development. Achieving and verifying that target requires continuous real-time measurement of the environmental conditions throughout the city: air quality, particulate levels, temperature, humidity, noise, and atmospheric chemistry. iLamp's air quality and weather monitoring sensors deployed at pole-to-pole density throughout the township provide exactly this measurement infrastructure. The CityWorks platform aggregates the sensor data into environmental dashboards available to residents, city managers, regulators, and investors. Air quality readings that are accurate street by street, not averaged across a metropolitan area. Carbon emission estimates that are grounded in measured atmospheric data, not modeled from consumption statistics. Environmental compliance verification that is continuous and auditable, not periodic and estimated. For a CIT IWERXS township seeking green building certification, carbon credit registration, or ESG investment ratings, the iLamp Environmental Sensor Network provides the measurement infrastructure that makes those certifications verifiable and defensible. The sustainability claims are not aspirational. They are measured, recorded, and reported continuously by the street lighting network itself. Application 3. Public safety, the intelligence layer. Public safety is one of the most powerful competitive advantages a CityWorks township can offer its residents. In India's existing urban centers, crime, traffic accidents, and public safety incidents impose enormous costs, financial, psychological, and social, on the communities they affect. A CityWorks township that can demonstrably deliver a safer environment, commands premium pricing, and generates the resident satisfaction that drives referrals and reputation. iLamp delivers public safety intelligence at a level that was previously available only to the most technologically advanced law enforcement agencies in the world. The 360-degree AI camera detects behavioral anomalies, a person in distress, a gathering crowd exhibiting pre-incident patterns, an unattended package in a public space. Gunshot detection algorithms in the audio processing system identify and geolocate firearms discharges within milliseconds, automatically alerting emergency services with precise location data before any human has called for help. The continuous video record, stored locally and managed according to privacy regulations, provides the evidentiary infrastructure that supports law enforcement response and prosecution. None of this requires a surveillance state architecture. The AI processing runs locally on the iLamp unit, with privacy-preserving edge processing that anonymizes pedestrian data before any cloud transmission. The CityWorks platform receives event alerts and aggregated analytics, not raw video surveillance feeds. The intelligence is comprehensive without being intrusive. Application 4. The CityWorks digital platform, powered by iLamp data. The CityWorks platform operates on a 7-layer IoT architecture: physical devices and controllers, connectivity, edge computing, data accumulation, data abstraction, resident-facing applications, and business process automation. iLamp slots into this architecture at the first 3 layers simultaneously, providing the physical sensing devices, the 5G connectivity infrastructure, and the edge compute capacity that the entire platform depends on. Resident-facing CityWorks services, energy management dashboards, safety alerts, traffic routing, environmental quality reports, community services booking, all become richer and more responsive when the underlying data layer is continuous, distributed, and street-level. A resident checking air quality on the CITIWERXS app receives a reading from the iLamp unit at the end of their street, not an estimate interpolated from a sensor 2 kilometers away. A parent receiving a child safety alert gets precise location data from the iLamp camera that detected the incident, not a neighborhood-level approximation. The intelligence of the platform is directly proportional to the density and quality of the data feeding it, and iLamp provides both at scale. Application 5. The AI Compute Revenue Stream, a new municipal income category. Here is the dimension of the iLamp integration that is genuinely unprecedented in the history of urban development. A CityWorks township deploying iLamp across its street network does not just acquire smart street lighting. It acquires a distributed AI compute asset that generates ongoing revenue from the global cloud computing market, completely independent of any resident-facing service, any municipal function, and any HYDC commercial activity. Consider the arithmetic for a typical CITIWERXS township. A 17-acre development with 1,000 to 1,600 residential units and the associated road network, public spaces, and commercial areas might deploy 500 to 1,000 iLamp units. At 9 cents per unit per hour, operating 24 hours a day, that network generates between $394,000 and $788,000 in annual GPU compute revenue. This revenue is not dependent on resident occupancy. It is not dependent on the health of the Indian property market. It is not dependent on any municipal contract. It flows from the global demand for AI compute capacity, a demand that is growing faster than any other sector in the technology economy and shows no sign of slowing. Over the 10-year life of the CITIWERXS 8-city development plan, across 130,000 homes and the associated public infrastructure, the iLamp Compute Revenue Network represents a substantial and growing income stream that compounds with every additional unit deployed. More township. Yes, more poles, more compute nodes, more revenue. A self-funding intelligence network that grows with the city it serves. Every streetlight in a CityWorks township is simultaneously a safety system, an environmental monitor, a 5G communications node, a traffic analyst, a drone station, and an AI compute farm earning revenue every hour of every day. The street lighting budget becomes a profit center. Part 6. The off-grid advantage. When the city stays up, there is one dimension of iLamp's value proposition that deserves particular emphasis in the Indian context, and in the context of any smart city that intends to offer genuine reliability as a competitive advantage, the off-grid capability. India's power grid is under strain. In many of India's existing urban centers, power cuts remain a fact of life, not a rare emergency, but a predictable daily or weekly inconvenience that residents and businesses have learned to work around. Backup generators, UPS systems, and battery inverters are standard equipment in Indian homes and offices precisely because grid reliability cannot be assumed. For a CityWorks township to deliver on its promise of superior quality of life, it must deliver something the surrounding city cannot: guaranteed continuous operation of all critical systems, regardless of what the national grid is doing. The turbogen microgrid architecture ensures that electrical power remains available, and iLamp ensures that the intelligence layer of the city, the sensors, the cameras, the communications nodes, the compute network, remains operational when the grid fails, because it was never dependent on the grid in the first place. When a monsoon storm knocks out power to North Bengaluru for 6 hours, the CityWorks township's streets remain lit. The safety cameras keep recording. The 5G communications network keeps operating. Emergency services keep receiving data. The AI traffic management system keeps routing vehicles around the flooded intersections. The CityWorks digital platform keeps serving residents. Because every iLamp unit is a self-powered autonomous node with its own solar generation and battery storage, the city's intelligence infrastructure is inherently resilient, not because it was engineered to survive grid failures, but because it was never designed to depend on the grid at all. This resilience is not just a quality-of-life feature. In a disaster scenario, a flood, an earthquake, a civil emergency, the iLamp network becomes critical response infrastructure. Emergency communications relay, incident location and reporting, crowd monitoring and management, drone deployment guidance for aerial assessment and delivery. The city that stays intelligent when everything else goes dark is the city that saves lives. When the grid fails, conventional smart city infrastructure fails with it. iLamp-powered CityWorks townships stay intelligent, connected, and safe because their intelligence was never dependent on the grid they were designed to make obsolete. Part 7. The CPG Connection, a partnership already in place. The iLamp and CityWorks convergence is strengthened by a partnership connection that is not coincidental. CPG Corporation, the former Singapore Public Works Department and one of the world's most respected urban planning and infrastructure organizations, is both a strategic partner of Huntington York Development Corp for master planning and construction management and a territorial license holder for iLamp deployment. CPG's role in the CityWorks program is foundational. They provide the institutional rigor, urban design expertise, and construction management capability that brings the Singapore standard of city planning to HYDC's Indian developments. Their involvement as HYDC's master planning partner gives every CityWorks township access to the same planning discipline that built Singapore into one of the most livable and efficient cities in the world. The fact that CPG is simultaneously a contracted iLamp territorial license holder means that the pathway from CityWorks master planning to iLamp deployment is not a new commercial relationship to be negotiated. It is an extension of a partnership already in operation across a company that understands both the physical infrastructure needs of a smart city and the commercial value of the iLamp platform. The integration is not theoretical. The relationships are established. The deployment can proceed from day one of construction. The franchise multiplier HYDC's long-term strategic vision extends well beyond 8 Indian cities. The CityWorks township model is designed for global franchising, deployable across India's 104 Tier 2 cities and then worldwide. Every franchise deployment carries the CITIWERXS platform architecture with it, including the iLamp Street Intelligence Network as a core infrastructure component. This creates a compounding deployment dynamic. As CityWorks franchises multiply across India and eventually across the world, The iLamp network embedded in each deployment adds to the global AI factory's compute network. Each new city strengthens the global network. Each strengthened global network generates more compute revenue. Each dollar of compute revenue reduces the net cost of the street lighting infrastructure in the next deployment. The franchise model and the AI factory's revenue model reinforce each other across every deployment, at every scale, in every geography. The ecosystem that AI Factories describes, iLamp, AI Factories, ILOCX, Conflow Power, Drone Ready, Speed Spotter, Tactics, and more than 80 additional AI applications being built on top of the network, maps almost perfectly onto the service requirements of a CityWorks township. Traffic intelligence, drone services, speed monitoring, tactical emergency response, AI-powered analytics. Each of these applications finds a natural home in the CITIWE-RXS environment, and each deployment in a CityWorks context creates another reference implementation that validates the technology for the next city, the next territory, the next franchise holder. CityWorks gives iLamp its most powerful proving ground. iLamp gives CityWorks its most powerful intelligence layer. Together, they demonstrate what a genuinely smart city looks like and make it impossible to build a city any other way once you have seen it work. Part 8. The 55 Million Light Vision. India. First, World Next. Step back for a moment and consider the full scope of what is being assembled here. Not just for CityWorks, not just for India, for the world. There are 55 million streetlights on this planet. Every government that installs street lighting pays to purchase, power, and maintain it indefinitely. Every city in the developing world, in Africa, Southeast Asia, South Asia, Latin America, the Middle East, faces a street lighting deficit that limits safety, limits commerce, and limits the quality of life of hundreds of millions of people. The International Energy Agency estimates that 600 million people in sub-Saharan Africa alone lack access to electricity, and street lighting in those communities is either absent or powered by diesel generators at enormous ongoing cost. iLamp addresses all of these markets simultaneously with the same hardware platform: solar-powered, off-grid, revenue-generating, AI-intelligent infrastructure that costs less to deploy than conventional street lighting, eliminates the ongoing power and maintenance cost entirely, and generates positive cash flow from day one through lighting service fees, compute revenue, and data intelligence sales. In India's 500 planned smart cities, the single largest planned urbanization program in human history, iLamp is not just relevant, it is essential. You cannot build an intelligent city without an intelligent street. You cannot build an intelligent street without intelligent infrastructure at street level, and you cannot justify the cost of that infrastructure unless it pays for itself. iLamp does all three simultaneously. For Huntington York Development Corporation, the strategic implication is clear. Every CityWorks township deployed with iLamp infrastructure is not just a better city for its residents. It is a node in a global network that grows more valuable with every unit added. A network that earns money from global AI compute demand, generates proprietary urban intelligence data, and demonstrates the future of city infrastructure to every government, developer, and investor watching. The 8-city CityWorks plan is the proving ground. The global franchise is the scaling vehicle. And the 55 million streetlights of the world are the eventual addressable market, waiting to be replaced, one pole at a time, by infrastructure that thinks. Epilogue. Edison would understand. When Thomas Edison lit the first commercial street light on Pearl Street in Lower Manhattan in September 1882, he was not just illuminating a road. He was demonstrating a new infrastructure paradigm, a distributed network of nodes, each generating and delivering a service, connected by a common platform, transforming the economics and the experience of urban life. The world had never seen anything like it. Within a decade, the model was universal. The iLamp team is right when they say their work is directly comparable to what Edison and Westinghouse were doing when they wired cities, just a modern, much-needed, and kind of obvious improvement. It is obvious in the same way that Edison's lights were obvious in retrospect. Of course, you would distribute intelligence to the street level. Of course, you would power it with the sun. Of course, you would monetize the compute capacity. Of course, you would use the lighting network to sense the city. Once you see it, you cannot unsee it. The only question is why it took this long. The answer is that it required the convergence of technologies that did not previously coexist in a commercially viable combination. NVIDIA's edge AI compute power in a module small enough and efficient enough to run on solar, 5G connectivity dense enough to make every pole a communications node, cloud AI workloads hungry enough to pay for distributed edge compute, battery technology reliable enough to run continuously without grid support, and a smart city platform sophisticated enough to use the data that the network produces. All of those technologies have now converged. iLamp is the product of that convergence. CityWorks is the city that harnesses it. And the 55 million streetlights of the world are waiting to be transformed from the most expensive per-unit municipal liability in history into the most valuable per-unit distributed intelligence network ever assembled. The city that sees in the dark is not a metaphor. It is a specification, and it is being built right now, one smart light at a time, in the fastest-growing cities on Earth, by a partnership that understands that the future of urban life will be illuminated not just by light, but by intelligence.